Okay, so for number 7, it's pre-calculus 30, section 3.4. Okay, we're talking about equations of graphs, polynomial functions. So for each function, determine. Okay, so for each function, determine x-intercepts. Okay, which come from the factored, I guess, version of the function. So we're going to have to factor in some cases. Well, I guess all cases, they're not factored. The degree and the end behavior of the graph. Okay, degree is easy. Degree is easy to see for all of these, right? It's the largest exponent that we see here on the variables. That's easy. The end behavior, so the degree followed by the leading coefficient, right, on that will indicate the end behavior. The zeros and their multiplicity, okay, so once we have x-intercepts, once we have the factors and the exponents on those factors, we'll get the multiplicity and the zeros. The y-intercept, who remembers what the y-intercept is in a function? Or in constant. Yeah, it's the constant, right. So if the constant is 0, as in this case, the y-intercept is 0, 0, the origin. Okay, that's also an x-intercept. Could be the only one, could be one of them. And if it's a constant other than 0, like -3 here, that's the y-intercept. Excellent. And then the intervals where the function is positive, intervals where it's negative. Okay, so we're going to have to take into account, you know, what the graph looks like, the end behavior, up, down, that sort of thing. Okay, so let's get into it. Let's just do one of these. Okay, for this first example. So let's do A. All right, so we're going to have to factor A. Now, we don't have to do long division or synthetic division for this. Do you know why? For A? Because, look, there is a common factor to all of those terms. And that common factor is x. So I can remove an x. I can remove an x from this polynomial, and this is what I get. So this is just like x minus 0 as a factor, okay? And it looks like I should be able to factor this further, just maybe by sight. So is there, or are there, two factors of 45, negative 45, that add up to negative 4? Okay, x minus 9, x plus 5. That's correct. So here we have our three factors. The x-intercepts will be where each factor is equal to 0. And because we let this equal to 0 now, we can solve for the zeros. So x is going to be equal to 0, positive 9, and negative 5. Everyone see that? Those are the zeros. So right away, we can start making a graph here if we want. I'll do that down here. And I can put those factors on there. So this is, or those zeros on there. There's 0. So a 9, let's put a 9 over here. Let's put a negative 5 over here. So we know that the graph is going to either cross or touch or be tangent to. Now what's the multiplicity now? Okay, so let's just skip to 3 because I just talked about the behavior at the zeros. What are the exponents on each of these separate factors? They are 1, 1, and 1. So they're going to just simply cross at each. Now, how do we know? How do we know whether it goes like this, and then like this, and then like this? Or if it goes like this, and then like this, and then like this? You have to look at end behavior, okay? End behavior. So it would be a good idea to do end behavior first. So the degree is 3. So we know that the end behavior, it's going to be kind of 1 up, 1 down diagonally, either this way or this way, right? The multiplicity end behavior dance, right? Okay, just like that. So if you're stuck for some moves, you know, end behavior dance, okay? Now, what is the degree? 3. It's 3. What is the leading coefficient? Positive 1. So that means the end behavior is going to be like this and like this. Okay, those are the two quadrants it's going to end in. So now we can start to piece together the graph. And we simply know that it's coming from down here. So it's going to cross here. Now it's got to come back and cross here too. So somewhere there's going to be a maximum point. It's going to have to bend back down, right? we know it's got to go back up. So somewhere in between here, it's going to be a minimum point. It's going to go back up like this, and so on. So that is a rough sketch of your graph. Now, do we know exactly how high this goes? No. Can you know? Well, we're going to study that in calculus, right? We're going to be able to find that out in calculus. How high and how low does it go? We don't know. All right, that we don't know. You don't have to know. Doesn't matter at this point, no. Doesn't matter at this point at all. Okay? All right, so what else? Intervals. So finally, intervals. Well, now that we have a graph, we can see from the graph what the intervals look like. Like, we know our division points are going to be at the zeros, right? So there's a division point, there's a division point, and there's a division point. And most likely the graph is going to be either above or below, after and before these points. So where the graph is, so intervals, now intervals means sections of the domain, okay, the x values, that correspond to the graph being above the x-axis, so in the positive y territory, and the graph being below the x-axis, then negative. So, so y is greater than 0, so that's positive, between what? -5 and 0. So y is greater than 0. Let me put this, I guess we could, domain. I don't know if there's a standard way of doing this, but y is greater than 0 when you can say x is between -5 and 0. That's the set notation there. And when x is what? So it's this area and way over here, right? X is greater than? Greater than 9. Good. Y is less than 0 when x is less than -5. See, it's everything before -5. And it's between 0 and 9. Okay? So you need to be able to do all of that for 3.4. And that kind of summarizes everything. It's intercepts, right? It's degree, it's end behavior, it's multiplicity, and it's positive, negative intervals of the function. Okay? Okay, so if we look at B, if we have y or f of x equals x to the 4th minus 81x squared, what you can do similar to A is you can take out an x squared here, can't you? And so this now becomes y equals x squared, and this is x plus 9 times x minus 9. That's a difference of squares there. So this squared here, this is interesting, isn't it? But this x squared represents a 0 at 0, and it also has a multiplicity of 2. So watch this. X squared can be written like this, x minus 0 all squared. You see that? So if you look at it this way, at the 0, there's going to be, it's going to be either coming down tangent to and touching and not crossing this way or this way, right? Depending on the end behavior. So this one here looks like, so we've got, it's even degree and it's a positive. So the end behavior looks to be this and this for B. Okay, this is B now. And we've got intercepts at -9, +9, and 0. You see that? So it's going to, the multiplicity at the -9 is just 1. So this is going to cross. The multiplicity at 0 is 2. That means it's going to come tangent to but not cross. So it looks like this. It bends back down. It just kind of goes up, touches, bends back down. And then, of course, it crosses through +9 as well. So it looks something like that. Okay, so this is what the graph looks like. We had to adjust the scale pretty intensely here to make, see, this is -1,000. So it dips down really hardcore there. Then comes up, and here's your 0, and there's your 0. So those are your 3 zeros there.
So we just draw it how we did? And then
Yep.
Okay.
Yep, this sketch is perfectly fine. You don't have to have scale here or anything. You just have to have the intercepts, the behavior, the end behavior, and the right. Yeah, that's really too bad. Okay, so there I said I wasn't going to do B for you, but I guess I did B for you. All right. I should really add C now, shouldn't I? Make you do one on your own.
Well, we have to do all of 7.
Oh, do you have to do all 7? Oh, yeah, good. It's 9 that we have to. Oh, right. 9. Good. Okay, so everybody got 7 then? Good at 7?